proximity to water. The last of the four, okay, this one we'll get into a lot of stuff, ocean currents, etc. But basically, I keep temperature range in mind. It makes a massive difference whether you are close to the ocean or far away, like us, for example. Temperature range, okay, either gets bigger the further away you go, or it gets smaller the closer you get, right? So keep in mind what we talked about in latitude. The further away you get from the equator, either north or south, things change. Latitude and proximity to water, they will change a lot of things, but you're always going to be warm when you're around the equator. But some things this might influence other things, whether you're wet or dry and warm. That would be a bigger difference. So for us, it would be a temperature range and a precipitation thing because we are far away from the equator and far away from the ocean versus somewhere along the equator. There are continental places along the equator and maritime places along the equator. They would be it's going to be warm there because of latitude, but generally the only exception would be what the ocean currents are doing. If you're bringing in a cold one, it's going to affect you differently than if you're bringing in a warm one. All right? So basically, temperature range is a big thing to focus on here. What helps to create this range? Basically, are you close to the ocean or not? That's kind of the big deal. Places that would have large temperature ranges would be like Winnipeg's a perfect example. Think of our highest temperature on a yearly basis and think of our lowest temperature on a yearly basis. Let's just toss out, if I can think on my feet here, I think our warmest average is around 20 and I think our coldest average is around -20. Obviously we have days that are hotter and colder than those, but those would be averages. So that's a 40-degree difference average between our coldest and warmest. Okay, if you go to Vancouver, they don't get as warm as we do in the summer, but they definitely don't get as cold as we do. So their temperature range would be a lot smaller. Okay, it would be about, I want to say 15 to maybe 0, maybe 5. So all of a sudden you're dealing with a 15 to 10 difference in temperatures versus a 40. We're on the same line of latitude, so that doesn't influence that at all. It's who's next to the ocean and who isn't. That's kind of the way you get. So, as I said, when you have a small or low temperature range, a place like Victoria, search up the latitude if you want, but I'm telling you, it's not really that different. We're both at about 49, and we both get very different temperatures. My dad lives there and he golfs in February. Nobody in their right mind is going outside in February around here. Okay? So this is basically another one of those relationships where as distance increases from the ocean, temperature ranges generally increase as well. So the further you get away from the ocean, the more variety you're going to have temperature-wise. Okay? So this is just, again, going into what I just talked about. Okay? So another thing that would be definitely noticeable would be the amount of precipitation. Okay? So continental versus maritime. Keep in mind we are a continental place. Maritime, I'll keep referring to either Vancouver or Victoria, one of the V's out there. If you're next to the big puddle, you're going to have more things falling out of the sky. Okay? And precipitation is anything that falls out of the sky. Okay? So rain, snow, sleet, whatever, that's precipitation. Hail, that's precipitation. So who gets more of it? Well, continental generally, and this is another thing that's completely different. When would you expect Winnipeg to get most of its precipitation? A lot of people say in the winter, because we can see the snow and how it piles up, because it doesn't melt. Okay? It just sticks around. But we actually get most of our precipitation between March and October, when it's warmer. Okay? And that just soaks in and we don't see it anymore. But the levels of precipitation generally, and this is a pretty strict rule for the most part, places that are far away from the ocean would get most of their precipitation when it's warm, okay? And Maritimes would be the exact opposite. If you look at a climate graph of Winnipeg and Victoria, Vancouver would be a better example. Victoria's a little bit different. Vancouver gets most of its precipitation between October and March, when we're the exact opposite. Why is that? Because of the ocean, okay? The ocean, remember, moderates your temperature, okay? So if you're dealing with pressure systems, what we just talked about before, we don't have any influence of ocean. But we do have a lot of influence in water in the summertime because of evaporation and the tremendous heat we get. That makes things go up. When moisture rises, clouds condense and things fall, okay? Out on the west coast, they don't have that heat that drives evaporation as much as we do, but they do have a puddle that never freezes right next door, which would kind of provide that moisture as air's coming off the coast. It gets blown up the mountains. As warm air rises, it cools and condenses. You get a lot of rainfall, okay? It's absolutely evident if you look at a climate graph of any of those two regions, precipitation-wise as well, okay? Ocean currents, much like prevailing winds, these are predictable. Migrating fish now would follow them, okay? If you've ever seen Finding Nemo, those little turtles that follow the currents, that is realistic, okay? It's basically you're on a little conveyor belt, okay? A lot easier walking on a conveyor belt instead of walking, right? If you've ever been on those airports. So imagine a bag carousel at airports. Okay, if you miss your suitcase, you know it's not gone. You just have to wait for it to come around again, right? And that's exactly what an ocean current does. It takes a long time for it to do its circulation, but it's got a very important reason for doing so, okay? We live on a ball. Most of our world is ocean. So this would be a massive influence on the world's climate, okay? Where it's warm, the equator, it's also warmer oceans, okay? If you go up north and go to the beach, it's not as nice, all right? So the oceans are warmer around the equator as well. Basically, a definition of an ocean current is the kind of the top level of the water. It's not the whole thing moving. It's not waves. This is kind of, again, like a conveyor belt, okay? But they have a very important reason, and climate change, as we pour more ice water into warmer oceans, is changing the salinity as well as the potential to maybe stop some of these ocean currents, which would basically devastate certain areas because these things moderate the world's climate, or specifically the places where these ocean currents hit the coast. Like the British Isles would be a perfect example, okay? They rely on the Gulf Stream that comes basically from the Gulf of Mexico, steamrolls across the Atlantic and brings warmer water. And when you have warmer water, here's another rule. If you have warm water, the air above it is generally warmer, okay? Cool water, the air above it is generally cooler. So, these ocean currents, funny enough, are either warm or cold compared to the surrounding water, okay? So where do they go? What do they do? Think of the balance that has to be created worldwide. Think of that conveyor belt thing that I was talking about. On my map over there that you can't see, I have blue and red lines going in kind of circles. This map that I'm going to show you here, but in a second, if you had a warm current, where do you think it came from? Okay, good guess would be the warm areas. Where do you think it goes? And think of trying to balance things out. Where do you think a cool current starts from? And where do you think it goes so that that balance is created? Think of that conveyor belt. Warm, moving to cold, back to warm. Cold, moving to warm, back to cold. Sometimes it takes multiple years, sometimes it does a whole circle in a year. They react differently. But if cold's going to warm, balance. Warm's going to cold, balance. And therefore nothing's too extreme. It's kind of sharing that temperature as if you were in a bathtub and trying to make the hot water go to the back, create this circle. Now everything's kind of the same temperature. Kind of nice. So this picture here, oh, you can see it. Well, at least you can see the arrows. The pink or the red ones would represent warm currents. The blue would represent cool currents. So I'm just going to highlight a few that I'd like. I don't know if you can see. This is North America right here. This would be the Gulf Stream, as I talked about the British Isles, which are right here, which would go starting from the equator and steamroll right through here. Okay? We have the Labrador Current coming right on top of Labrador here and bringing cool air, or sorry, water down here. These two here, and for this is Vancouver, Victoria, wherever you want to talk. This one here is quite interesting because I've experienced this personally. I went surfing in Tofino in July, okay? You have to wear a dry suit. Now a dry suit is different than a wet suit because a dry suit doesn't allow any water in because the water's like 3 degrees, 5 degrees. It's absolutely, like my feet got numb in July. It's nice and hot outside, but the water is freezing. So think about that balance. When does Vancouver get its rainfall again? I just mentioned it. Generally in the winter. So when do you think that warm current is around versus that cool current? Cool one's around in the summer to keep the temperatures a little bit lower. Warm one's around in the winter to keep the temperatures a little bit warmer, okay? One big thing that I didn't mention that I will right now, warm air contains moisture way better than cool air. Think about our winters when it's minus 40, there's no clouds in the sky. It is sunny and beautiful, but deadly, okay? It's too cold to have moisture in the air. So it'll only snow when it's kind of closer to minus 10 or 0. That's generally when we get our snow. Okay, if you see a bright sunny day, don't worry about it. Stay inside, light a fire, find a happy place. It's cold. Okay, so these things, again, is kind of consistent with what I told you before. Maritime places get most of their rainfall in the winter and less of it in the summer. So less when there's a cool current around, dragging along cool air, less moisture, less precipitation. Warm current comes around in the winter, brings up the temperatures, moderates them a bit, but brings moist, warm air, what do you know, more precipitation. Okay, here's just a local example. The Gulf Stream, again, steamrolling past here, the Labrador Current, they meet right off the coast of Newfoundland, and then again, you get a freshwater current coming out of the Gulf of St. Lawrence from the Great Lakes, etc. So you have 3 different kinds of water meeting right there. Where they meet, Josh, it's the foggiest place on the planet. Better stay out of there, okay? It's very foggy. A lot of fishing going on there because you're getting very shallow water with warm, cold, fresh water mixing. A lot of fish, a lot of food, a lot of sunlight. One of the best fishing places on the planet. Okay? Warm and cold currents, I'll finish off with this. Cold currents move water towards the equator, and warm currents move water towards the poles. Okay? For example, these would be some names of currents. I don't really like the Labrador Current and the Gulf Stream. Those would be some I've just mentioned. Not a big deal. So the effect of these currents, this is what I was talking about. The cool currents would bring less moisture and bring cooler temperatures. Okay, the warm ones would warm the temperatures generally in the winter months. So pay attention to the seasons. And again, if you look at a climate graph, which I will show you in a second, rainfall temperatures pretty consistent in terms of when they happen around that. Okay. One thing that I will, well, sorry, this is what I'll finish off on with ocean currents and stuff, every once in a while, and we had one recently, I believe 2015, we'll find out. There's something that affects specifically the warmer currents. El Nino. Anybody know what El Nino means? It's a little boy. Okay, no. It's there's El Niñas, which would affect the cool currents, but the one that really does a lot of crazy stuff would be the El Niños. They are the ones that warm the warmer currents more than usual, and therefore would create worldwide events, even here in Winnipeg and in more continental places, because they change the prevailing winds as well. Droughts would get drier, a lot of floods. So past El Niños brought us the flood of the century here in Winnipeg. Past El Nino events have brought the ice storm in Quebec in '98, one of the worst global storms in history at the time. Past El Ninos have kind of incredible droughts. Think of all the wildfires that have happened in the last 5 years. Probably going to get worse. Okay? So around the equator, warmer water, when they warm more than usual, which probably will happen again. Okay? It's 97 as well as 2015. I was right. These are some past events, and you can see based on radiation, the warmer currents are just a little bit warmer than usual, which drives, again, think of the rotation, and most of the world is water. They would have a big influence. Okay?